Good evening. So, welcome to the week 10 live class of the course Basic Environmental Engineering and Pollution Abatement. So, I'm Niketa and I'm a PhD student from IIT Madras and I am your TA for the live session. So, before I start, I want to ask if you have any questions from this week's lectures or from any of the previous week's lectures. Okay, so if there are no questions, I'll proceed further. So, what I'll do is I'll give a brief overview of some selected topics that you may have seen in this week's lectures, and then I'll proceed to a question and answer session where I'll give some multiple choice questions for which you will have to answer. Okay, this is how I do my live sessions. Okay, so let's proceed. Is my screen visible? Okay. I'm having some technical issues with sharing my screen. So, okay, so let's discuss about some industries that we saw that you must have seen in the last week's lectures. So, you must have seen about the sugar industry. So, basically, what happens in a sugar industry is sugarcane is processed and then it is converted into sugar. So, there are different kinds of wastewater that come in the sugar industry. So, there is wastewater coming from the fermenter, and the fermenter needs to be cleaned frequently. So, clean fermenter cleaning water and also the fermenter cooling water will also be released, and there is also condenser cooling water and floor washing water. So all of these are um, wastewater streams that contain heavy organics because the fermenter itself will have a lot of organic load. So cleaning the fermenter will also give us many alcohols and unprocessed sugars and so on. And then there are other streams of wastewater water as well, like bottling plants and spent wash, etc. But these bottling plants and spent wash wastewater do not require any treatment because the all these parameters are within the limit. So there is no treatment required as such. Okay, so the distillery, the treatment scheme goes as follows. So first, the distillery wastewater, it is taken for evaporation, and in the evaporation unit, there will be water vapor that is released, which will be condensed, and then it will be taken to a condensate polishing unit, and then from evaporation, it will be taken to the concentrate. After evaporation, the remaining remaining stuff will be taken to the incinerator. But before taking for the incinerator, it will be concentrated, and post incineration, it will be taken to a potassium recovery unit. So whatever remains in the distillery wastewater, it will go for biomethanation, and from biomethanation, it will go to a two-stage aerobic treatment process, and after that it will go for tertiary treatment and surface water recharge. So this is how the scheme goes. And this is week 10. Week 11 will be next week on Monday. Okay. And then there is this multi-effect evaporator where RO reject will be used as the feed, and whatever waste is generated, it is complying with so because this is used as a feed, it is compatible with the zero liquid discharge norms. So zero liquid discharge means that whatever waste is generated in the treatment plant will be reused and it will be recirculated within the plant itself. so that there is no other, no reject stream that is going to be let into another, a waste, a water source or a water body, etc. So whatever wastewater or wastewater is generated, it will be recycled and reused within the plant itself. So that's what zero liquid discharge means. Just give me a moment. Sorry, I forgot to turn on the mic. So I was just going through the treatment scheme in a distillery wastewater, and once the first step involves evaporation, and after evaporation, we have to concentrate the solids, and then after concentrating the solids, we have to go for incineration. So my question is, what is the meaning of incineration, and how is it different from burning? What is incineration? It's okay even if your answers are wrong. We are all here to learn. So, Priscilla, can you answer this? Okay, is incineration a thermal process or not? I just wanted to understand, what you think of incineration. Okay, so incineration means the controlled, you would say, controlled combustion or controlled combustion of material in the absence of oxygen. So during burning, we let the combustion take place in an open atmosphere where oxygen is also present. It in fact drives the process, but during incineration, we completely remove the oxygen and we just allow the combustion to take place. And here the temperature and everything, all these things can be controlled. So it is a controlled process. Even the mixing rate, generally during incineration, we will provide mixing so that the heat is uniformly spread out through the material and the combustion process also becomes uniform. So the heating and the temperature and even the stirring speed, all of this can be controlled in an incinerator. So generally, incineration is preferred because it requires less energy and it also releases less byproducts. For example, pyrolysis, all these processes are used for taking out valuables from solid waste. So that is why incineration is preferred, because burning is an oxidative process where a lot of harmful gases can be released. Okay, so then after incineration, in the ashes, we can get potassium recovery. We can remove the potassium from it and we can maybe use it for other purposes. And the second way is by taking it for biomethanation. And after biomethanation, we take it for two-stage aerobic treatment. And whatever waste is remaining after this two-stage treatment, we take it for tertiary treatment. And the water that is released after the two-stage treatment is taken for irrigation. Okay, after tertiary treatment, the treated water can be used for surface water recharge. So surface water recharge means basically letting the treated wastewater into lakes, rivers, ponds, etc. because now it is treated and it complies with the norms. And after bioremediation, whatever slurry is remaining, that can be taken for evaporation. So either it can after bioremediation, it can go for anaerobic, it can go for aerobic treatment, or it can go through evaporation and concentration and incineration. So this is the flow chart. And then we were talking about a multi-effect evaporator. So here, whatever RO reject is there. So generally, when you have a reverse osmosis membrane, under high pressure, only water is allowed to pass through the membrane, and whatever solids are there, they will be remaining. They will be highly concentrated, and that all the solids that are not allowed and not being allowed to pass through the membrane, they will be taken out as reject. So the reject will actually have a higher concentration of solids, salts, etc. And instead of wasting it, here it has been used as a feed for the multi-effect evaporator. So this essentially means that whatever wastewater is generated in the RO stream, it is not being discarded as such, but instead it is being rerouted and it is being sent to the evaporator. So this ensures that the zero liquid discharge norms are being met. So what is this zero liquid discharge or ZLD norms? It means whatever wastewater is generated, it should be reused and recycled, and there should be no discharge into the, there should be no discharge outside. So discharge means whatever wastewater is there, letting it out of the industry or putting it out into the environment is called discharge. So by following zero liquid discharge, we will be conserving water. We won't be letting the wastewater go out of the premises of the industry. Instead, we will be looking at ways to reuse the water. Okay, then we have the condensate polishing unit. So here the feed from the condensate that we saw previously, the evaporator will also have, after evaporation, whatever vapors are generated, they will be taken to a condensate or a condensator, and they will be condensed in a condensate polishing unit or CPU. So what happens here is the condensate will come to an equalization tank. Condensate means anything that requires to be condensed. So the condensate will come to an equalization tank. So can you recall what is an equalization tank and why do we need an equalization tank? So you must have studied about this in the primary treatment. Why do we use a equalization tank? Priscilla, can you answer this? What happens in an equalization tank and why do we need it? Am I audible now? Am I audible? Oh, okay. So I was asking, what is an equalization tank, and why do we need equalization tank? So you must have studied equalization tank in the primary treatment process for wastewater treatment. So why do we need equalization? Okay, so during wastewater treatment, in a wastewater treatment plant, the wastewater inlet can come from various sources. So, and not just various sources, they can also come at different times, and sometimes the flow might be high, sometimes the flow might be less. So during peak hours, that is from in mornings and in evenings, there will be a lot of wastewater which is generated, and also the flow will be high at these times. But in the lean period, that means in the afternoons and late mornings, so during this time the wastewater flow will be very less. So because of these reasons, the flow to the wastewater treatment plant will be varying. So in order to equalize this, or in order to normalize this flow, we are using an equalization tank. And also an equalization tank will also ensure that the wastewater is having uniform characteristics, like uniform, because it's coming from different sources, it may have varying concentrations of pollutants. So in order to equalize that and also to equalize the flow rate, we are using an equalization tank. Yeah, that's what. Okay. So after equalization tank, it will go to a condensation tank, or sorry, conditioning tank. And then this is followed by biological conversion, or a bio process, an anaerobic process from which flammable gases are released. So if there are flammable gases, it is not good practice to just release it into the environment, because if the concentration or the volume of this gas is quite high, then it won't be a good idea to store it or to release it as such. So that is why we go for gas flaring. So gas flaring means burning the gas so that it does not harm anyone. So it is a controlled burning where whatever gas is generated, it is flared by fire, putting it to fire, so that it doesn't get spread out or cause any harm. And after this, after biological conversion, the liquid comes to aeration tank. So what is the purpose of an aeration tank? Why do we need an aeration tank? Yeah, because mostly we go for aerobic treatment process, be it activated sludge process or um, trickling filter. So all these are aerobic processes in which we need oxygen supplies. Oxygen is for the bacteria to grow because along with the organic substrates, it also needs oxygen for its metabolism and for its growth and multiplication. So that is why we need to supply oxygen, and for this we are using an aeration tank. And aeration tanks usually have aerators. Aerators are like they can be of different types. So one is from the bottom we can aerate using proper blades or something, or we can even have aeration provided from the center, like it will be one common aerator for the whole tank, or we can even have aerators which are coming from the top. So that mixing, so all these are basically mixers which will ensure the water comes in contact with air, and air will oxygen from the air will get diffused and dissolved into the wastewater. We can even supply O2 gas directly, so that is also possible. But again, it's an expensive process, so we don't usually go for that. We usually go for mechanical aeration. Okay, next we have the secondary clarifier. So, what happens in a secondary clarifier? What happens in a secondary clarifier? Yeah, so sludge settles because after aeration, after biological process, we will get sludge, and that sludge needs to settle down because we have to separate it from the liquid. So for that, we are providing a settling tank, which is the secondary clarifier. So what about primary clarifier? Why is that used? No, a primary clarifier is basically used to settle down the bigger solids, or maybe the what to say, for coagulation, flocculation purposes, we use the primary settling tank. But after that, after coagulation, flocculation, we will go for aeration, and from there we go for secondary clarifier. Is that clear? Okay. And after secondary clarifier, there is another step, which is the tertiary treatment. So tertiary treatment involves processes like filtration and all the membrane processes, and even some advanced processes, etc. So whatever sludge is generated, it can be used for making manure, and the filtrate water will again be redirected to the aeration tank. So after filtration, again the reject will be there, just like how we get reject for RO. So this will be redirected back to the aeration tank. So from aeration, again it will come to secondary clarifier, tertiary treatment, and this is like a cycle. And after filtration, there will be some solids. After tertiary treatment, there will be some solids also. So those solids will be used for manure. Okay, and then we come for air and noise pollution. So what are some of the sources of air pollution? So mainly CO2 is generated during fermentation. And this CO2 is processed and then resold. And the second one is from evaporators. So there could be some gases which are produced along with water vapor. And the third one is power boilers or the cogeneration process. So here a combination of gases like sulfur dioxide, carbon monoxide, NOx, and carbon dioxide are also generated. Okay, coming to noise pollution sources. Can you name some noise pollution sources in a sugar industry? So we are talking about sugar industries here. So can you tell me some sources of noise pollution in sugar industries? Jag reheating. Can you think of any other steps which will produce noise? See, in a sugar industry, what happens? Sugar canes are processed. How are they processed? Sugar canes need to be cut and shredded, right? So the shredding unit will produce a lot of noise, isn't it? Yeah, so shredders. And there can be also the evaporator washing. Any other options? Generators, not so much, but there can be leaks from uh, steam vents, or there are pipelines carrying steam, right? Then, if there is a leak in the pipeline, then that will generate a lot of noise. So, steam leaks, and also from steam vents. So once steam is produced, it needs to, when there is an outlet for the steam to come out, so that time, because of the high pressure in which the steam is coming out, there will be a lot of noise. So steam vent will also produce noise. And then during evaporator washing, again noise is produced, and also during power generation. So how can we control the noise pollution? Yeah, we can go for sound barriers, or we can also called as silencers, or we can even give the employees or staff personal hearing protection devices. What about controlling air pollution? So to control air pollution, we need to maintain a proper stack height. So this is necessary because otherwise, what happens if we don't maintain a proper stack height? whatever pollutant is generated, high chances are that it could be very near to the ground and it could come to the ground. So if the atmospheric conditions are such that there is inversion or there is some reason why it cannot flow upwards, then it will be very easily it will come down and it will pollute the inhabitants. But if the stack height is higher up, then there are high chances that even if there is inversion, the pollutant will not get dispersed in a short distance. So it will take some time for the pollutant to reach the ground surface, and even upon reaching the ground surface, if the stack height is high, even upon reaching the ground surface, the pollutant concentration will be dispersed. So it won't be like a very concentrated stream, it will already be diluted. So that is why we need to maintain a proper stack height. And then we need to have equipments for controlling the pollution. Okay, what is oxidation? What do you mean by oxidation? And what are the byproducts that you think will come out? I'm not understanding what you are saying here because, see, oxidation. Are you talking about catalytic oxidation using catalytic converters? And then you are also saying byproducts. So I'm not clear what byproducts are we talking about here. So, okay, let's move on. So now we will be looking at a leather industry. So leather is produced in a process called tanning. So tanning is producing leather by processing animal skin. So now we'll be looking at the different processes which are used in a tanning industry or a leather processing industry. So first process is soaking and liming. So here the flesh is removed. So even after removing the skin from the animal, there could be some residual flesh which is sticking to the skin. So that is removed in the first process. And then there is fleshing, which involves, so the first process is chemical and this process is mechanical flesh removal. And then there is deliming and beating. So this is done for improving the chromium impregnation. So chromium is usually used in dyeing industries to enhance the color and also to improve the texture. So deliming process will improve the chromium impregnation into the leather, into the dead skin. And then there is tanning. So here chrome sulfate is added. So chrome sulfate is the chromium salt which is used for this process. And then there is dyeing. So dyeing improves the appearance. So depending on what kind of finish we want and what kind of color we want, we can change the dyeing process accordingly. And then there is fat liquoring. So this will help the leather fibers slide smoothly over each other. Otherwise, it's just going to be a very hard substance without any flexibility. So fat liquoring actually helps the fibers to slide over each other. And the last step is called finishing. So this is done to, here some chemicals or finishing agents are added to make it more attractive. Okay, so this is a brief of all the processes that are done in a tanning industry or a leather industry. Now coming to the wastewater that is generated in these processes. So what could be the possible wastewater sources? First one comes from the soaking unit. So here the animal skin is soaked, and from this also wastewater this wastewater could be highly rich in organics. So that is the first one. And then there is also the wastewater generated from the liming process and the fleshing process also. And then there is wastewater coming from deliming unit and also from the pickling unit. And then during chrome tanning. So this stream of wastewater is particularly high in chromium. So chromium, as you know, is a heavy metal and it is also a good, well-known carcinogen. So it could cause cancer at high concentrations. So that is why it is important to treat this water and remove the chromium before releasing it to the environment. And then other streams of wastewater include splitting, shaving and trimming wastewater. And rechroming and retanning wastewater. And also wastewater from dyeing and fat liquoring. So generally, the wastewater that is generated in the tanning or leather industry is split into two streams. Uh, the first one is the chrome containing or chromium containing wastewater. Like I said, chromium is a heavy metal which is carcinogenic. So this stream of water which contains chromium is separately collected and it is treated separately because the treatment involves steps which are additional to the usual treatment process. So that is why it needs to be treated separately. And the chromium will be, once the treatment is complete and the chromium is removed, that will be recovered and stored. And then there is the non-chrome wastewater or wastewater that contains more of organics and which don't have any chromium. So how is the chromium recovered? So chromium is precipitated. So we add agents like magnesium oxide and sulfuric acid. So by these, the chromium will get precipitated and it will settle down. And the remaining water will be treated for, it will be high in organics and it will go for non-chrome separation. So whatever chromium is there, it is precipitated by adding magnesium oxide and sulfuric acid, and it will be collected as a solid. And the remaining water, that is the top, the chromium will be precipitating at the bottom. So whatever water is remaining without chromium at the top, that will be separated and it will be mixed with the non-chrome wastewater. And the non-chrome wastewater will undergo the usual process, microbial degradation. So now coming to air pollution. So can you name some air pollution sources in a leather industry? What are some sources of air pollution? So after all these processes, when we get raw leather, we do surface coating on it. So the surface coating will produce a lot of volatile organics or volatile organic compounds or VOCs. So this can be prevented by using roller coating, HPLP spray guns or airless spray guns. And the ammonia and hydrogen sulfide, these can be removed by wet scrubbing. And whatever VOCs are generated, so whatever VOCs are generated, they can be removed by using again wet scrubbing or mostly adsorption, because that is easy, or we can go for wet scrubbing. So can you tell me what is wet scrubbing? What happens in that? What happens during the wet scrubbing process? How is it done? Yeah, so water is introduced and it is sprinkled basically. So the sprinkling makes sure the water droplet sizes are small, and smaller droplets will have a larger surface area. So that will mean that if the diffusion or the mixing of the gas into the liquid will be higher. So for that to happen, we need to make water droplets. So that is why we use sprinklers. Okay, next is the petroleum industry. So here, crude oil is converted to products like liquid petroleum gas, kerosene, diesel, petrol, and so on. So, what are the wastewater sources here? See, animal fur cannot be called particulate matter because it is bigger than 10 microns. Obviously, it's going to be bigger than 10 microns. So it cannot come under the category of particulate matter. In fact, whatever animal fur you cut, that is going to come down and settle anyway. So that will come under solid waste. And I don't think that comes under leather industry, because even leather industries buy. I mean, they buy raw hide. So they don't generally cut the animal skin. So that is usually done in another place. So they take the cut skin and then they process it. Okay, so what are the various wastewater sources in our petroleum industry? So petroleum industries usually take crude oil, right? So if we have crude oil, then there will be oily effluents from various processes. And there is spent caustic, and effluent from regeneration. And there can even be sanitary waste. So, what are some major contaminants in a petroleum refinery plant? So, the major contaminants are mostly oil refineries will also generate oil containing waste. So, oil is the most common contaminant. So, this can be either free or in emulsified form. If it is emulsified, then it will be mixed with water. So, this oil that is present as free oil that can be separated using a tilted plate interceptor. So tilted plate interceptor is mostly like a skimming unit where the top surface is skimmed off. So because oil floats usually at the top, so that is just intercepted and it is collected and removed. And for emulsified oil, we can use air flotation. By passing dissolved air through it. So whatever oil is there, it could come up to the top. And then suspended solids. So this can be removed using alum. And then there could be phenols, even sulfides, and organic matter. So the process is usually like this. First, the free oil is removed. And then we have some physicochemical treatment processes for sulfide and emulsified oil removal. And then there is biological treatment. And polishing. And then sludge management. And finally, chemical dosing. So during sludge management, the sludge is usually thickened and centrifuged, like what we saw in the previous live class. And then the concentrated water is sent for oil water separation. And then whatever solids are there, they will be made into a cake, and that cake is sent to a secured landfill. So what are the air and noise pollution sources here? So there can be emission from stacks. And there can be sulfur coming from fuel oils. So in order to remove all this, we need control equipment and processes. So for control, we can go for desulfurization. We can even have sulfur recovery units. And low NOx burners. Low sulfur fuel oils. Where the sulfur concentration is less than 1%. And we should also go for tall stacks and high efficiency heaters with low excess air. And for the hydrocarbon gas that is produced, we can have floating roof tanks. Okay, now coming to paper industry. What are the possible sources of wastewater in a paper industry? Yeah, pulping. Second, debarking. The third one is bleaching and recovery. Fourth one is the washing process. And finally, the actual paper making process. So the paper industry is a highly water intensive industry and it generates about 70 meter cube of wastewater per ton of paper produced. So for the wastewater treatment, the first process is primary treatment. And then anaerobic digestion. So what do we get from anaerobic digestion? What happens after? What are the products that we get after anaerobic digestion? Yeah. So methane is CH4, by the way. Methane and generally biogas is produced. So biogas is a combo of methane and carbon dioxide. So after anaerobic digestion, so the wastewater is taken for aerobic treatment. Anaerobic digestion is only for the solids, and the treated wastewater is then taken for irrigation and tertiary treatment. And the sludge from anaerobic treatment is taken for evaporation. Oh, sorry, the sludge from aerobic treatment. It's taken for evaporation and incineration. Or landfilling. So then, coming to fertilizer industry. So the waste generated comes from the dust, from phosphate rock grinding, and then emission from scrubber and curing shed. And effluent from the scrubber. Condensate. Compressor and boiler. And flue gas, which comes from boiler. Carbon dioxide, the condenser vapor, and ammonia is discharged from the ammonia plant. So mainly we have nitrogen related waste that is coming out of the fertilizer industry. So the best available techniques for nitrogen removal. They are steam stripping or water scrubbing, or biological treatment. Biological treatment means nitrification and denitrification. So, can you tell me in brief what is nitrification? What happens during this? What do they do? Nitrifying bacteria is right, but what do they do? What actually happens in the nitrification process?
Ma'am, ammonia is converted to NO2.
Yeah. And what about denitrification?
It's inverse of that.
Inverse. How? Okay, if we had to do inverse, then why did we do denitrification in the first step?
Ma'am, denitrification means, I think, removing those nitrifying bacteria after the treatment.
No.
Means that are
See, nitrification and denitrification are both processes that are done in wastewater treatment to remove nitrogen. Both are, one follows the other. So, first there is nitrification where ammonia gets converted to NO2, like you said, NO2 or NO3. And then this NO2 or NO3 is again converted to nitrogen, elemental nitrogen in denitrification step. It's not the inverse. Inverse would mean that whatever nitrates and nitrites are generated during nitrification is not converted to ammonia. Instead, the NO2 and NO3 are converted to nitrogen, elemental nitrogen.
yes, ma'am.
Yeah. So biological treatment can be done where N2 will come out as gas, and then we can also do ion exchange for removing nitrates. Okay, now coming to copper smelter industry. So here the sources of air pollution can be the volatile organic compounds from smelting, and acid mist and particulate matter from the sulfuric acid plant. And then particulate matter, metals, SOx and NOx, dioxins and furan. So what could be wastewater sources from the copper smelting industry? First one could be the process water, from hydrometallurgical processes. Then wet off gas cleaning, then slag granulation, and cooling water, and then surface runoff or storm water. So how is the wastewater treated? So the metals can be precipitated by using hydrated lime. Then the acid needs to be neutralized. And heavy metals like arsenic, they can be co-precipitated with iron 3 oxide or Fe3O4. And how do we control the air pollution? So we can use filters. To control acid mist. And then wet scrubbers or mist filters to collect and treat acid mist. And then we can even install hoods on tanks and maintain a foam layer on the surface. And we can even treat exhaust gases and mist using scrubbers. So this is all about air pollution. Now coming to VOCs especially. So VOCs are produced during solvent extraction and venting out the storage tanks where the solvents are stored. So for this we can use water-based solvents. We can use mixers or settlers. And scrubbers, biofilters, bioreactors, carbon traps, chillers, etc. So all of these can be used for trapping the VOCs. And then for controlling dioxins and furans, for this we need to eliminate the organic materials before going for heating or combustion, because dioxins, furans are generated at temperatures above 550 degrees. So in order to avoid their production, we need to remove any organic compounds that are present. So this can be done by removing organics. And then we can use activated carbon in a fixed or a moving bed, so that whatever dioxins or furans are there, they can be absorbed. And how do we do noise control? So we can either give work rotation, meaning the workers can be asked to work in shifts, or we can provide them with personal hearing protection devices. So yeah. So do you have any questions from today's class? I just said work rotation means asking the workers to work in shifts. Like some person can, someone can work in the morning and another person can work in the afternoon. So this will minimize the exposure to noise. So if there are no more questions, we will go for the multiple choice questions. So the first question is,
I'm not sure about this.
okay, so the Maillard reaction is very common in food or in food processing industry. So generally what happens is, you must have seen that when you caramelize sugar, so sugar is initially white, but after heating it for some time, it turns into,
Brown.
yeah. So this is because of Maillard reaction. This happens because of like oxidation, and the sugar will caramelize, and in that process it will turn into brown. So Maillard reaction causes brown colored pigments. So this also happens with proteins. So like you can even observe it on roti, chapati, even dosa. So all these contains carbohydrates, which are nothing but sugar and proteins. So this also can be observed in when you cook meat like in an oven, or maybe like when you fire it, then you can observe the browning. So this is because of Maillard reaction. Second one. So tannery sludge constitutes what percentage of anthropogenic chromium pollution? So we just saw what processes happen in a tanning industry, and I told you that chromium is used for getting a proper color. So like what percent that chromium will be taken out as wastewater. So the question is, how much will that contribute to anthropogenic chromium pollution? By the way, anthropogenic means it is man-made. So what's the answer?
No idea, ma'am.
So the right answer is 40%. This is because chromium is, biological process will not work for treating chromium, and it cannot be used in agriculture or any other process. During agriculture or any other reuse cannot be done. And incinerating the chromium containing waste will make chromium come out as gas. So again, that will cause air pollution. So tannery sludge will contribute 40% of anthropogenic chromium pollution. Next question is, so the question is, why is urea added to refinery wastewater? So the first option is to remove oil. Second one for sulfide removal. Third, it is a food for bacteria. And then last one is for sludge management. So what is the correct answer? So go back to oil refinery industry. So once the oil is removed, whatever wastewater is there, for that treatment, why is urea added? See, once you remove the oil, there is not much organic content left. So it's mostly inorganic matter that needs to be treated. But there is still some organic matter but bacteria will not be able to survive using that.
I
So
think it will like provide nutrient to the bacteria, organic bacteria present in the wastewater.
yeah, that's what I was going to say. So it will act as a substrate or food for bacterial growth because the organic content is very less, so the bacteria will not be able to survive using that, and therefore the process will be inefficient, and the whatever residual organics are there, they won't get broken down. So urea is added to as a food for bacteria. Next question. So the next one is, which of the following is called wet blue?
Can you please read the options?
The first one is tanned hides, second one is finished leather, third one is fleshed hide, and the last one is pickled hide. So hide is nothing but animal skin that has been cut and harvested. So wet blue means which of the following?
I think answer is either A or D. I think D. D is the answer.
No, the correct answer is tanned hides. Because once the tanning process is done, the skin will be blue in color. So that is why it is called wet blue.
But in D option, there is the chlorination process. Pickled
Yeah,
hide.
obviously, pickle means adding salt to it, so that is not the right answer.
Okay.
So dissolved air flotation is used for removing which of the following? First option is free oil, second one emulsified oil, third one heavy metals, and last is all of the above. So we just
Answer is emulsified oil.
Yeah, so we just discussed this when we were talking about refinery waste. So free oil is skimmed out and emulsified oil is removed by flotation. So when you supply air, dissolved air, so all of the emulsified oil will form as foam and then it can be collected. Okay, so with this we have come to the end of today's lecture.
Ma'am, free oil is separated on the basis of density separation.
Which one?
density separation. I mean,
Yeah.
using bands.
Any other questions?
No, ma'am.
Priscilla, do you have any questions? Okay. Okay, so I'm ending this session. So let's meet on Monday for the next live session. Thank you for joining.